This is the first video on chapter 42, surface area of the solids of revolution. So solids of revolution, surface area, part 1. So the idea here is that we have this function and we're going to rotate this about the x-axis, and that makes a three-dimensional solid. And in Calculus 1, you learn to find the volume of that solid. But here we're going to learn how to find the surface area. Surface area formula is a little more complicated than the volume formula. So for this particular example, we have y is the square root of x minus 1. X ranges from 1 to 13, and we're going to revolve this around the x-axis, and that will give us our solid. So we're going to use the arc length formula. We're going to use the surface area formula, which means we're going to integrate this expression here. So 2 pi times the function, then we have the derivative squared plus 1 under the square root. You'll recognize this part here as arc length. So we're going to simplify this expression. The derivative, we just use the power rule and the chain rule to find the derivative. And this is the expression we're going to integrate, and so we'll simplify it. We'll just substitute 2 pi. This is our function. Then we have the y prime squared plus 1 is this right here, and we're taking the square root of that expression. And so we're going to simplify this algebraically. Because this is an Honors Calc 2 class and not an algebra class, I won't work through the steps, but this expression that we have right here simplifies to this. If you have difficulty doing that on your own, ask me in class and I'll show you how we get from here to here. But it's just algebra. So now we have a function to integrate. We integrate from 1 to 13 of pi times square root of 4x minus 3. This is just finding an antiderivative. This is actually a Calculus 1 problem. So we find our antiderivative. We'll substitute 13, we'll substitute 1, then we'll subtract. And that simplifies to 57 pi.